In the partial fraction work we've done in the previous video, if you go back and look, you'll notice that the highest power on top of the fractions is always lower than that of the denominator. We've got to ask ourselves, what happens though if the power on top, the highest power, is equivalent to the highest power on the denominator? Because that then means we've got to start to combine a couple of techniques in order to get it to a point where we're actually able to express it in partial fractions. We can't do it straight off if the power is equal to or greater than that of the denominator. Now, if that's the case, what we have to do is use algebraic long division to fix this, i.e. we have to use algebraic long division to split that top up and then get it to a format where we can then take the part of the fraction that's left, i.e. the remainder, and then use that to express it as partial fractions. Again, the easiest way to show this is with an example, so here we go. Let's imagine I want to express the following as partial fractions: x squared plus x plus 1 over x squared plus 3x plus 2. Now, one of these ones, you look at it and you ask yourself, right, what's the highest power on the top, what's the highest power on the bottom? Well, an x squared on top and x squared on the bottom, we have to make sure that the top has a lower power that is the highest of the bottom. So what we then have to do is use algebraic long division in order to split this. So we take the denominator and we put it outside, so x squared plus 3x plus 2, and under the division we've got x squared plus x plus 1. Now you should remember the technique for this. Take the number in front here and we divide that by it, so x squared into x squared gives me 1, and then we do 1 times the expression outside, so x squared plus 3x plus 2, and I subtract them from one another. So x squared minus x squared is nothing. X minus 3x gives me negative 2x. I've then got 1 take away 2 gives me negative 1. So this one here, I can actually rewrite it as negative 2x minus 1 over the denominator. However, if I look at the denominator, x squared plus 3x plus 2, this can actually be factorised into x plus 2, x plus 1. So we do that in order to then see what format we can have it in for our partial fractions. So I'd write my denominator as x plus 2, x plus 1. So what that means is I've got distinct linear factors on the bottom, so I know it's going to be written in the format a over x plus 2 plus b over x plus 1. So this remainder has to be written in this form. This part here, where we've got our answer from our division, will come into play at the end. We'll need that as part of our answer, but right now the focus is on writing this out in partial fractions. So again, for this, we want to get rid of the denominator, so we're going to multiply through by x plus 2 and x plus 1. What that then means is that negative 2x minus 1 equals a times x plus 1 plus b times the x plus 2. Same drill, substitute values of x in to find the a and the b, and then we can combine the whole lot together. So if I pick x is equal to negative 1, what that means is on this side I've got negative 2 times negative 1, so 2 take away 1, which gives me 1. That then equals, well, a disappears, and then for b I've got negative 1 plus 2, which is 1, so that equals b. So another b is equal to 1. If I then choose the value of x is equal to negative 2 to eliminate the b, what that then means is my left hand side becomes negative 2 times negative 2, so 4 take away 1, so that's equal to 3. I've then got negative 2 plus 1, which is negative 1, so negative a just left there, so I then know that a is equal to negative 3. So I can then take this part here and express it in partial fractions overall, and I can use that then for the whole thing. So I could then say, fine, so my x squared plus x plus 1 divided by x squared plus 3x plus 2 equals, well, I've got my partial fraction bit, but you've got to remember you've got this here first. So what this means is when I get my final answer, what I've got is I've got the answer from my division plus my two fractions. So then if plus a over x plus 2 plus b over x plus 1. That is now going to be the format of our final solution for this. So in this case, it's 1 is the answer. So I'm going to get 1. I've then got plus a over x plus 2. Well, a is a minus 3, so I'm then going to take away 3 over x plus 2. I've then got plus b over x plus 1. B is equal to 1 plus 1 over x plus 1. That there's my final solution. I've now got a number in front that is not part of a fraction purely because I've done algebraic long division to get there. But if you go and check this, combine the whole spiel together, you'll find that that's the correct answer. Another example of this, let's look at this one. So I've got x cubed minus x squared plus 2 over x squared minus 2x plus 1. Again, looking and comparing the highest powers, this one here is bigger than this, so what I have to do is I have to do my algebraic long division. So I've got x squared minus 2x plus 1. What that does is that's going to go into my x cubed minus x squared. Now remember, there's no x term here, so I'm going to fill that gap with a plus 0x, then plus 2. Just saves any confusion as we're working through for when we do our subtractions. So we then start working our way along. We take x squared into x cubed. So I get x, take this and multiply the whole thing here by it. So I get x cubed minus 2x squared plus x, and then I subtract them. So x cubed minus x cubed is nothing. Negative x squared, take away negative 2x squared. So negative x squared plus 2x squared gives me x squared. No x, take away an x, gives me a minus x. Then I've got a plus 2. Now if I look here, my highest power here is equivalent to the highest power here, so I go yet again. But because they're equivalent, I know this is the last time. So x squared into x squared gives me plus 1. And then multiply again through by the whole thing. What I get is x squared minus 2x plus 1, and I subtract them from each other again. So negative 1 take away negative 2x gives me 1. Negative 1 plus 2x gives me x. I then get 2, take away 1, which is plus 1. The x squareds cancel because of that. So what that means is I've got this is my answer, but this is my remainder. So what I can then do is rewrite this fraction here to look at the remainder as being x plus 1 over the denominator. Now again, I can look at the denominator to factorize it, and I get x minus 1 all squared. So what that means then is my final answer is going to be this bit here, my x plus 1 plus my partial fraction section, which is a over x minus 1 plus b over x minus 1 squared. And I know it's going to be like this because I've got a repeated linear root on the bottom here. So let's turn that into partial fractions now, and I'll see what my final answer is. So I've got x plus 1 over x minus 1 all squared equals a over x minus 1 plus b over x minus 1 squared. Again, I want rid of the denominator, so what I'm going to do is multiply the entire thing through by x minus 1 squared. What I then get is I get x plus 1 equals a bracket x minus 1 plus b. So I need to put in values for x to find my a and my b. Easiest one to start with to eliminate a is if I pick x equal to 1. What I then get is a 2 on this side. A's disappear, and that equals b. So I know my b is equal to 2. If I then pick x is equal to 2, what that then means is I get 2 plus 1, which is 3, and that's going to equal 2 minus 1 times a, so 2 minus 1 is 1, so it's going to equal a plus the b, and I know that the b is 2. So a plus 2 is equal to 3, I then know that a is equal to 1. So now that I know these two values here, my value for b and my value for a, I can put them into this and get what my final solution looks like in terms of an answer from the division plus my partial fractions. So what I can then say is fine, so I know my x cubed take away x squared plus 2 all over the x squared minus 2x plus 1. That can be written by the answer from the division, so the x plus 1, then my partial fraction section. So plus a over x minus 1, plus 1 over x minus 1, plus b over x minus 1 squared, and I know b is 2, plus 2 over the x minus 1 squared. So when it comes to the partial fraction section, there is no difference. There's just one extra step, and what that is doing a bit of algebraic long division, so this wee section here, to get an answer for when I do that calculation. And that then just adds an extra term into my solution right at the start. There's no difference in terms of overall general technique for the partial fraction section itself. That's the only additional step, and it will maybe add one layer of complexity to it, but it's a technique we should be familiar with by now.